towards piecewise functions that are not necessarily absolute value functions, right? Because all we're doing is, I mean, if piecewise functions existed only to rewrite absolute value functions, then I would question why we would have to have absolute value functions to begin with, right? Piecewise functions are themselves their own entity. So what we're looking at are graphs of parts of separate functions. All right, not necessarily absolute value functions. All right, can be made up of any function. So we're talking linear, polynomial, absolute. Those are the ones that we've learned about. I'll say et cetera to account for the ones that we haven't learned about yet. All right. All right. So what it allows us to do is take information about one graph, evaluate it, and then maybe move on to another graph later on. The important thing to realize here is that in the real world, things don't just follow a particular graph. Like if you were to follow money over a period of time, you might say that it has a linear relationship, but can you count on that linear relationship happening forever? No. Eventually it would transition to something else, maybe another line, maybe a different type of function. The height of a human, that seems very steep in a linear fashion early on, but then it levels off as the individual gets older and older. So for a young child, you might be looking at a very, very steep rate of change, but then as a person gets into their teenage years, adulthood, then the rate of change gets less and less, right? So the change in your height over, let's say, the last year, I guarantee it was not the same rate of change as it was when you were going from age 2 to 3, right? So you might say, well, I grew 6 inches. Yeah, but compared to what your original height was, as a percentage of your original height, it's not going to be as significant. I mean, you're talking like in the age of 2 to 3, or even 1 to 2, a child's height doubling. Did your height double in the last year?
No.
Probably not. In the rare circumstance it might have, it would be weird. Beginning of the school year, somebody's 4 feet tall. End of the school year, they're 8 feet tall. Like that's something, Like I'm sure it's happened somewhere, but because everything's happened somewhere, but it's not something that's very likely to happen. All right. So different models take place over different portions of maybe a person's life, but also when you're dealing with money, when you're dealing with vehicles, like in fuel consumption as a car gets older, it doesn't consume gas the same way as it does when it's a younger car, so things like that, right? So those are some applications. Here we're just actually plugging and chugging, right? For these kind of problems, these are very nice. These are ones that maybe you look forward to, because all you're asked to do here is evaluate the function. First thing you need to do is determine what piece of the function makes sense, all right? So f of 2, which piece makes sense? All right, would it be the first piece or the second piece? First or second? Reading top down. Second. Think about it. Look at the domain. This is saying for all x values that are less than -1. Is this number less than -1? No. All right, so it would not make sense for the first piece. All right, because again, this is f of x. That makes the 2 an x value. All right, so what I want to do is I want to pop the 2 into only the second piece. Right? Because if you plug it into both pieces, you'll get an answer. It just might not make sense. Right? But the problem is that you've experienced this. You know. All right, I'll just put it this way. What do you get when you plug a 2 into the first piece? 10. All right, so that'll be choice C, right? And then 0 will be choice D on the test. All right, so that's what's going to happen. You're going to plug it into the wrong piece, and it'll appear as a choice, and you'll get the wrong answer. So you got to be careful. You can't just plug it into whatever you want. There might even be a choice that says 0 or 10, 0 and 10, you know, to account for both of those answers, to see if you really know that it doesn't make sense to go in here, but it does make sense to go in there. It all has to do with the domain. That's why we spent so much time talking about the domain. All right, which piece makes sense in B? The top one, the first piece. Cool. So plug it into the first piece. What do you get? -4. What about C? First piece, second piece? Second. So we're going to do f of 0 is equal to -4 times 0 plus 8, which is 8. That's nice and easy. And then the last one, which piece? Second. So f of -1, -4 times -1 plus 8 will give you a 12. All right, so the graphing, right? If you think about what we did on the previous page, nothing different. Make a table of values. For each one, use your calculator as a support if you want. We have y equals 2x plus 4. The only challenge that's going to come into play here is knowing open circle versus closed circle. It's not even really a challenge, it's just knowing a fact, which requires studying. The only thing that's getting an open circle on this graph is the coordinate at 1, because that's the one in the second graph that you can't actually get to. All right, so this is an open circle. Everything else is going to get a solid point. All right, if it has an equal sign in it, it has a solid point. So we plug and chug. All right, so, and again, just use some information to your advantage. Like, for example, if I plug in a 0 here, I get a 4. That's easy. That's easy to figure out. I have a slope of 2, which means that there's a rate of change of 2 as I go down the line. So I'm increasing by 2. So I can fill out this table just with that knowledge. All right, so this would be 6, 2, 0, -2, -4. All right, I didn't need a table for that. But you're welcome to use a table. Sometimes it's not as necessary as you might think. All right. This one, I think, is probably easier to just do the computations because it's 6 minus whatever the x value is. 6 minus 1 is 5. 6 minus 2 is 4, 3, 2, and 1. All right. you'll notice in this case how at the x value of 1 for the first graph we have a 6, at the y value, the x value of the second graph we have a 5. They're not the same location. So the closed circle is not going to fill in the open circle. So we got to be careful about that.
Wait, aren't you not allowed to use 1 and 5 or 1?
That's why we're putting in an open circle there. Open circle tells us that we can get very close to it, but we'll never actually touch it.
Okay.
So -4, -4, -3, -2, -2, 0, -1, 2, 0, 4, 1, 6. All right, I'm going to put a smooth, or attempt to draw a smooth line through that. With an arrow, because, oh wait, not with an arrow, right? This one is finite? Yeah, it stops at -4, so we don't want to go arrow. We're going to go point to point. All right, open circle at 1, 5. All right, it's a little harder to draw, so I'll just tuck it in there. But that's where my 1, 5 is going to be. 2, 4, 3, 3, 4, 2, 5, 1. And again, this is a finite graph. It's not going out to any kind of infinity, so we don't put arrows on it, right? It's starting and stopping for the first graph between -4 and 1. It's starting and stopping in the second graph between 1 and 5. All right, so we do not put arrows on it. If you put arrows on it, it's incorrect, right? So you got to be very careful about that. Right, but table of values, point to point. It's only if it says something like x is less than, x is more than, that you swing it out to infinity. But these are not those situations. Now the last problem there does in fact allow us to go to some kind of infinity. Right? So in that case, really, I mean, I just used in the last problem in number 2, I used all the values between -4 and 1, and then all the values between 1 and 5. But here I just need to use a selection of values that are less than 1 and a selection of values that are more than 2. Right? Knowing what my boundaries are. So for this one, y equals -2x minus 6. I want to be less than -1. So I'm going to max it out at -1, but I'm going to do that with an open circle. And I'll choose some values that are below -1. So -2, -3, -4. And I'll use my calculator. If I don't want to do the math, I'll use my calculator. All right. Sometimes even if I do want to do the math, I'll use my calculator anyway for fear of screwing it up. All right. But anyway, this is going to be -4. If I plug in a -1, 2 minus 6 is -4. And then plug in a -2, I'm looking at 4 minus 6 is -2. So I have the trend here. I'm increasing by 2 as I go up the line. So 0 and then 2. So you can go to the calculator, but sometimes again you don't need to. Y equals 1/2 x minus 6. This one starting at x value of 2 and increasing from there. All right, so if I plug in a 2, 1/2 of 2 is 1, minus 6 is -5. I'm going to ignore the odd numbers because I don't want to deal with plotting fractions, so I'm just going to ditch those bad boys. The reason I can do that is because this is a linear function, and all you need to plot a line are 2 points and a ruler. So if one of them is the endpoint, I'm good to go. So just for the sake of not making my life miserable, I'm just going to ditch the fractions, or the odd numbers, which will make fractions. 4 multiplied by 1/2 is 2, minus 6 is -4. So I could just plot those. 2, -5. And then 4, -4. And it is a line, so you can count on the slope. It's up 1/2. Just use that slope to fill in the rest of the way if you want to do a freehand. Generally, if you want to do a freehand, you want to have more points. If you're using a ruler, you don't need as many points. And I prefer to go freehand because I don't feel like getting up to get a ruler. And again, same deal. Once you see what the trend is, I'm going up 2/1, up 2/1, and so on. Use that to fill out the graph. Again, if you're using a ruler, you don't need to, but if you're doing it like I am, you don't lose credit on this Regents exam if your lines aren't straight. Right? Next year, that's a different story, because there's part of the course that involves constructing graphs using appropriate techniques, and that involves rulers and compasses and things like that. In that case, your graph based on the quality of your drawings. Here in this course, you're not graphed on whether your line is perfectly straight. It's got to go through the appropriate point stuff. So if it's got like a shaky countenance like mine does, that's fine. I can't draw a steady line. I can't even hold my hand steady anymore. So what does it matter, right? As long as you get through the important points, you're in good shape, right? And you'll also see that there's a gap between these 2 points. That's consistent with the gap between the upper bound of my first graph and the lower bound of my second graph. So that should make sense now.
If you like plot or put like the y equals 2x plus 4 on the graph, and then erase things that are like the x values that are less than
Yeah, you can do that. Whatever makes sense to you. This is the way I like to do it. If you like a better way, or maybe not better way, but if you like a different way, that's perfectly all right. As long as it gets the job done. Just be careful of the instructions. It's very, very rare, but sometimes questions do call for a table of values. If they do, you gotta get the table of values, as annoying as that might be. All right.